Hello everyone, welcome to the end of 8.1. This week has got a lot of content, okay? 8.1 in 2 parts and 8.2 in 2 parts, okay? So there's 4 videos and notes that we're gonna do here, but 8.2 is gonna be a lot shorter. But anyway, let's get into this. So if you remember, at the end of, or essentially what we did at the beginning of 8.1, we're talking about graphing. And if you have a function that looks something like this, y equals sine of bx minus c plus d, we said there was a couple things that we could think about and talk about when we do this, okay? That's a B, not a 6, come on. So, A, that's the amplitude, and this can be sine or cosine. Amplitude, right, if you're looking at some kind of sine wave, right, amplitude is how high is your high and how low is your low. It's the distance to the top or the bottom from the middle, okay? If my cat stops messing things around, we can get to what B is. B relates to the period. Remember, period is going to be 2 pi divided by B in absolute values. C is related to the phase shift, which is C over B is our phase shift, which is a horizontal shift. And then finally, D is a vertical transformation, and D is corresponding to our midline. So let's do a brief bit of review, kind of bring it all together. I think this is example 6, which looks very differently from a B. Okay, in example 6, we said determine the midline, the amplitude, the period, and the phase shift. Okay, figure everything out about this function, because we're going to be using this for graphs. All right, and essentially the core of this section is being able to do this. Being able to do this given a function and being able to do this given a graph. Okay, so part A, we got y equals 3 sine of 2x plus 1. So again, we need the midline, we need the amplitude, we need the period, and we need the phase shift. So just write down what we need, and then we can start doing what's necessary to get it. So usually start with the easier stuff. The amplitude. Again, the amplitude is just the number in front of the sign. And this says that we go up 3 and we go down 3 from the middle. So amplitude is just 3. The midline is this plus d at the end. And you might say, well, what plus d? There is no plus d. Exactly. So there is no vertical transformation. The midline here is the x-axis, or the line y equals 0. Again, it's a midline. It should be the equation of a line. All right, so I'm not going to be super picky on that, though, if you forget the y equals. It's important, but not important enough for me to take off points. The period, right? We said the period's 2 pi over b. What is b? B is 2. So period is going to be 2 pi divided by 2, or just pi. And lastly, the phase shift here is going to be negative. It's going to be the opposite of what you think, because in this equation we have bx minus c. So the phase shift is going to be negative c, which is 1, over b, which is 2. And there's different ways to write your phase shift. I may have talked about this in the last video, but one of the ways is to just use the signs. Positive or negative. But I think it's kind of confusing. So a lot of times you might just want to say, okay, it's 1/2 to the left. All right. Because this sign will always be opposite of this sign. I feel like this is just a lot more clear for you and for me. And we can maybe eliminate confusion if we just talk about it in these terms. All right. So that's essentially all you're doing. Write down what you need, and then look at the various values of A, B, C, and D to get what you need. So we're going to do part B. See if you can figure out where we need to go before I get there. Y equals 1/2 cosine of x over 3 minus pi over 3 plus 1. Okay, so again, we're going to need the midline, the amplitude, the period, and the phase shift. So we're going to start with the easy stuff. Amplitude is always A. Amplitude A. It makes sense. Same letter. And it's going to be this number right here, just 1/2. The midline is D. The midline, yeah, D for the midline. Anyway, it's just going to be this. It's going to be y equals 1. Period, be careful here, period is going to be 2 pi divided by b. But what is b here? B is not 3. B here is actually 1/3. Be a little careful on this one. All right. Right? It's x over 3 is 1/3 times x. So b is 1/3. So period is going to be 2 pi divided by 1/3. We can write 2 pi is 2 pi divided by 1. And then we just multiply by the reciprocal. 2 pi times 3 over 1. Multiply that across. You're going to get, our period here is 6 pi. Okay. And again, one way to think of period is the standard period is 2 pi. If we have a 2 in front, that doubles the speed. So it's going to take half the time. Now the period's only pi. Over here, the standard period's 2 pi, but we're dividing by 3. We're slowing it down by a factor of 3. So it's like multiplying by 3. We get a period of 6 pi. And finally, the phase shift is kind of the most obnoxious. We said B was 1/3. Well, C is positive pi over 3. So the phase shift is going to be C divided by B. It's going to be pi over 3 divided by B. But again, dividing is just the same as multiplying by the reciprocal. And we're going to get a period of just, or a phase shift of just pi. And again, this is going to be the right. Remember your function transformations. If you're subtracting on the inside of a function, that shifts it right. If you're adding, it shifts it left. So you can either, again, express your answer in 2 ways. Either with positives and negatives, like we did right here, or specifying whether it's to the left or the right. I like specifying whether it's to the left or the right, less confusion, but it's up to you. So now we're going to get into the heart of this section, and that's going to be interpreting graphs. So let's do this the easy way instead of the hard way. Instead of me just showing you on my own paper what graph we want to use, let's actually just do it. So hold on, I gotta do this undercover real quick. I'm gonna plot the graph and we need to find the equation for it. All right, so should be this. Oh, this is not good. Hold on. I input it wrong. It's gonna be one. There we go. That was the graph of secant, by the way. If you guys are excited for talking about secant, that's gonna be 8.2, which we're gonna be doing. All right, don't cheat. Oh my word. We're gonna be doing 8.2 tomorrow. Okay. So let's have this step be in like pi over 4, like this. All right, we need to figure out what graph this is, and no cheating. So this is going to be example 7. The idea was that this was going to be a much better way of doing this. And let's change the y just going up to 2. Make this a little easier to read. All right, this graph, we need to find an equation for it. So example 7 says determine formula. Why am I writing this down? You can't even see this. Determine the formula for the following. All right, part A is, I'm going to give you a hint using cosine. All right, so let's go back to it. So we have this graph over here. Here, hold on. Let's use our brains here. We can do 2 at once. So we need to find and look at a couple things. Remember, the standard thing we're going to be looking for is y is equal to a times the cosine of bx minus c plus d. So we just need to find out what are the different values of this. Okay, so let's start with the amplitude. Let's start with the midline. Usually starting with the midline is one of the best things to do. So over here we're going to say, all right, what's the midline? Midline is just the d. So what is the middle line? What is the middle of this graph? It's going to be this middle. It's kind of hard to see, but it's going to be between the minimum, which is 0, and the maximum, which is 1. So the midline is just going to be 1/2. So d is 1/2. All right, let's do this while we're doing it. So y is going to be a times the cosine of some stuff plus 1/2. Well, then the amplitude is just the distance between the middle and the top or the bottom. The distance between the midline and the max, which is 1. The distance between the midline and the minimum, which is 0. So the amplitude is actually also going to be 1/2. And now you have two. Well, let's talk about the period next. Period is how long does it take to repeat? So if we start at negative pi, go down, and then we go over here at pi, what's the distance between these 2 points? The answer is 2 pi. If you look at another way, right? We start down here at 0, go over here at 2 pi. Period is 2 pi. And this is where things get tricky because we actually sort of go backwards. The period is 2 pi, but that doesn't tell us what b is. But we know, right, that the period is 2 pi divided by b. Well, if I know the period, let's plug that in. And then we can solve for b. This one's kind of a simple case, right? So we have the period, which is 2 pi, has to be 2 pi divided by b. Multiply both sides by b. You're going to get 2 pi times b equals 2 pi. Divide both sides by 2 pi, and you get b is 1. So it's just 1x. You don't need to write the 1. And now you have an option here. You can either say, well, there's a phase shift of pi, right? Cosine normally starts at the top. You say we have a phase shift of right pi units and use that to find c. Or there's an easier way. Instead of starting at the top over here at pi, let's start at the bottom, right? And if we start at the bottom, then we have no phase shift at all. And the way to start at the bottom is just making the amplitude negative, or making a negative. Amplitude's always positive. So we can actually just ignore the phase shift and have this be our answer. But again, if we wanted to, we could keep a positive a and use a phase shift, and we could use a phase shift of pi. So again, there's infinitely many answers for this sort of problem. All right, and you can choose whichever answer makes the most sense to you. And let's hope that this is actually what I had. Oh, negative 1/2 cosine of x plus 1/2. Great. So we got the right answer. Let's do the next one. It's going to be part B. We're going to use sine for this one. All right, so let me secretly type in this formula that you're not going to see. All right. So that's going to be our formula right here. And let me go ahead and change these. Let's have the y-axis going from like -1 to 4 or something. Look a little easier over here. All right, so we just need to start asking some questions, just like last time. Find out what the midline is. That's going to tell us what D is. Find what the amplitude is. Find what the period is. Find what the phase shift is. And then we're going to write our answer as something like this. Midline is 2, exactly, yep. It's just where's the middle of the graph. The zeros right here, 1 and 2. And let's make this look a little cleaner. Great. So the midline's y2, which means we have a +2 at the end right here. All right, the next usually easiest thing is the amplitude. And again, the amplitude right here is just the distance between the midline and the max and the min. Well, we start at 2 and we go up to 3. That's a distance of 1. We start at 2 and we go down to 1. That's also a distance of 1. It should be the same distance, right? So our amplitude is just 1 here. That's nice. So we can write a 1 here, or we can just not write anything. Let's next up find the period. How long does it take us to start repeating? Hold on. Why is it not letting me click where I want to click? I want to show these points right here. This one. I want to show this point. It's not letting me highlight this point, but it's 3.14. That may be a familiar number to you. Or you could look over here. But the idea is, right? Oh, I'm blocking it. All right, you can see that it repeats every pi. All right. Every pi, the sine function starts repeating. So if the period is pi, again, we have to use that information to say, what is b? Because period is 2 pi over b. And we found the period. But we need to find b, because we need to fill in this formula here. So we get pi has to equal 2 pi over b. Solve this equation just like you did before. I'm not going to solve it for you. You know how to solve this equation. And you get that b is 2. So it's going to be sine 2x. And then is there a phase shift here? No. Sine starts in the middle. If this were cosine, we'd need a phase shift because cosine starts up here. But it's sine. Sine starts in the middle. We're already at the middle. We don't need a phase shift. Phase shift moves things to the side. So that's our final answer. One such final answer. If you really wanted a phase shift, you could make it negative sine. And you might be saying, neither of these have phase shifts, Jason. Give me some phase shifts. Well, your wish is my command. Let's do part C. I'm going to tell you you can use either sine or cosine for part C. All right. And here it's going to be, oh my word. I don't actually have the function written down. I just have the graph written down in my notes. So you're kind of stuck with this. Oh dear. I have to do the math in my head, which is bad. I should have prepared better. This doesn't look good. Hold on. Here we go. We're getting closer. I'm going to do this off so that I can off this video right now so that you can see it, so that you cannot see it. All right, here we go. Oh, no cheating. No cheating. All right, we need to, let's get this graph and let's get it from, x goes from like -3 to 8 or something. Let's have y going from -8 to 2 or something. Oh, we need something bigger. All right, so let's look at this graph. So this is where things start getting a little bit more exciting. But again, we're just going to follow it and do this the same way. Amplitude, period, phase shift, and midline. So first off, whether you choose to use sine or cosine doesn't matter for this one. But some of them might be easier than others. For example, I would be tempted to use cosine on this one because cosine normally starts at 1. And here we have a cosine. Here's where the top of the graph is, and it's very easy to see this point. Okay, so we can say, well, we'll have a cosine starting here. So there is going to be a phase shift here. So, excuse me. Let's, I'm going to use cosine, but you don't have to. So y is going to equal to something times cosine of something plus or minus something. So let's start with the midline. Midline's usually easiest to start off. Midline's not super easy to see right here, but the highest point is when y is 1, and the lowest point is when y is -5. So what's the average between 1 and -5? What's the middle of 1 and -5? It's -2. So the midline's y equals -2. So we're going to have a -2 at the end. Yes, very good. So then the amplitude is just, okay, how far is this middle from the top and from the bottom? Well, it's 3 away from the top and it's 3 away from the bottom, so the amplitude is 3. Again, didn't we already have an amplitude of 3, 1? Anyway, now the period's kind of hard to see here. I'll zoom out a little bit. Is how long does it take before it starts repeating? So we start off at 1 when x is 1, and then we go through a bit of a zoop-de-zoop. We're up here at 25. So what is the difference between 25 and 1? So the period is 24. Goodness. So we need to use that to find out what b is. So period, which is 24, is equal to 2 pi divided by b. Multiply both sides by b, you're going to get 24b equals 2 pi. Divide by 24, you're going to get b is 2 pi over 24, which simplifies to pi over 12. And all that's left is the phase shift. So if this were a normal unphase shifted cosine function, then this point would be actually over here. Cosine starts at the very top when x is 0. But this was bumped over 1 unit. So our phase shift is 1 to the right. So we know this is going to be a minus sign right here because function transformation tells us if we subtract from the inside, that moves it to the right. Then we have to find out what the value is. Okay. So we know the phase shift, but we don't know what c is. Because again, phase shift is c over b. So phase shift we know is 1. And that's going to equal c, which we don't know, divided by b, which is pi over 12. Multiply both sides by pi over 12 to find out what c is. And then you're going to get pi over 12 times 1, that's just 1, equals c. So pi over 12. Whoops. Sorry, y. I cut you off. This should be our answer. Moment of truth. Is this what I typed in to Desmos? Y equals 3 cosine. Yes, it is. Great. All right. And that's a big chunk of the problems. I can guarantee there's going to be one of these on your quiz for this module. All right. So be careful with those. All right. Next big chunk is graphing functions on your own. That's going to be example 8. There's some really cool application problems in this section that we're actually not going to talk about, but they're really cool. But again, I'll have to hold myself back. We'll be skipping them. Example 8 is the last thing, just graphing. So graph the following. And I made a mention of this on your quiz, but you don't have to use graph paper. I would highly recommend using graph paper. Graph paper makes this a lot easier to have good looking graphs, but I'm not going to dock you points if you don't use graph paper. Also, I'm not going to be using graph paper right here. So if you don't have graph paper, you don't need to get it. You can just do what I'm right about to do here. So when you're graphing this, just like before, every single problem in this section, you want to find the amplitude, the midline, the period, the phase shift. If you can do that, it makes your life much, much easier. So let's make a little list. Amplitude, period, midline, phase shift. So the amplitude is going to be the absolute value of A, which is 2. The midline is going to be this plus D. That's just the line y equals 0. Phase shift, well, there's nothing added or subtracted in here. That's also 0. And the period is going to be 2 pi divided by this. So it's going to be 2 pi divided by, or multiplied by the reciprocal, 2 over pi. And it cancels to just become 4. So when you're graphing these trig functions, what I really like doing for myself is just starting with kind of a blank graph and dividing the period into 4 parts. So here, dividing the period into 4 parts is very natural because the period is 4, so we can just count by ones. But in the future problems, we're not going to be counting by ones necessarily. You can define your axes to have whatever scale you want. So splitting up the period into 4 parts usually makes things a lot easier. All right, and the midline 0, so we can have this graph centered. If the midline were above, then we don't need all these negative. If the midline were really, really low, we wouldn't need all these positives. And the amplitude is 2. So we know we're going to go up 2 and we're going to go down 2. So we've got most of the information that we need. Sine starts in the middle. The midline is at 0, and there's no phase shift. So this is where we're starting this graph. If there was a phase shift, we'd start here, but then bump it over to the side, and that's where we'd start. Now, every quarter of a period, so every hash mark in how we're doing this, we are going to go either from the midline or to the midline to either the maximum or minimum. And sine normally starts by going up. But because our A value is negative, that's going to be flipped, and now we're going to start going to the bottom. And again, if you divide your period into 4 parts, every quarter of a period, you just go back and forth between the midline and either the max or the min. So we're going to go down to the min, then back up to the midline, up to the max, down to the midline, and we could repeat this forever if we wanted to. Let's go look at the negatives. Keeps on going up to the max, down, back to the midline, down to the min, back to the midline. And now we have this very beautiful sine curve. And again, this goes on forever. And by very beautiful, I obviously mean my graphs don't look great. Your graphs don't need to look great either. I don't expect more from you than I expect from myself. They just need to be clear enough that I know that you know what you're talking about. All right, and that's essentially it. Let's do 2 more parts of this. Parts B and C. And then that'll be it for this section. We'll start 8.2, which will be shorter tomorrow. Part B, graph f of x equals 3 sine pi over 4x minus pi over 4. Good, we got a phase shift on this one. Good practice to do phase shifts. So let's figure everything out. Amplitude, period, midline, phase shift. We need all of it. The amplitude is this number in front. It's going to be 3. The midline is this number at the end. There is none, so it's going to be y equals 0. The period is going to be 2 pi divided by this. 2 pi divided by pi over 4. Same as multiplying by the reciprocal of pi over 4. The pi's cancel, and we're going to get 8. The phase shift is C, which is pi over 4, divided by B. Dividing by B is the same as multiplying by its reciprocal. And again, this whole cancels out. The phase shift is 1. And is it to the left or the right? It's to the right. So let's make our axes again. Again, the midline is 0, so we can have a nice centered graph. The amplitude is 3, so we're going to go up 3. We're going to go down 3. And then again, I like having the period just split up into 4 parts. So let's count by 2s this time. Nobody said we always have to count by 1s. So here's 8. So this is 2, 4, 6, 8. Let's count by 2s. Because again, usually for graphing these, the easiest way is just to divide the period into 4 parts. And then the phase shift is going to make things a little more complicated. So we're starting with sine. Sine starts from the midline. And the midline's at 0. So sine would normally start here, just like we did in A. But we have a phase shift, so we're not starting here. Phase shift in midline is going to change where we start. The phase shift is 1 to the right, so we get bumped over 1. And again, this is 2 over here. So 1 is actually between 0 and 2. And now, every point that we do is going to be in the middle of 2 hash marks. Because when we move forward a quarter of a period, sine says you're going from the midline to the maximum when you go a quarter of a period. So we're up at 3 here. Then we go back to the midline and back to the minimum. And all of these points, if you divide your period into 4 sections, all of these points are going to be in the same part of every section. In this case, our phase shift was 1 to the right, so all these points are going to be in the very middle. And again, we could go the other way too. The very middle of every hash, alternating between the midline and either the maximum or the minimum. And then, once you have all your dots, you just connect it in that beautiful wavy way that we all know and love. And that's our function. That's our graph. Now, let's get to the part C, which is going to have a little bit more excitement. Keep on putting my hand on my phone. Do not want that. Part C is going to be y equals -2 cosine of... I'm going to change this problem actually. Show you something a little bit more similar to something you're going to see on your homework. X over 2 plus 1. All right, plus 3. I'm going to change this from what I was planning on using for the example. All right, so again, it's always going to start off the same way. Every problem in this whole section is going to start off the same way. Find the amplitude, the period, the midline, the phase shift. All right, in any order you want. I usually like going midline, amplitude, period, phase shift, but it doesn't really matter too much. So the midline, we actually have an interesting midline now. It's going to be this 3. Y equals 3 is going to be our midline. The amplitude, again, amplitude's always positive, so even though it's a -2 for A, amplitude's going to be the absolute value of that. Amplitude's going to be 2. The period's going to be 2 pi divided by 1/2. Remember, B is 1/2. So 2 pi divided by 1/2 is 2 pi times its reciprocal, 2. Period here is 4 pi. Finally, the phase shift is C divided by B. 1 divided by 1/2 is also... Ooh. I don't want to make it this nasty, actually. Let's slightly change this. It's over here to a pi. Let's have C be pi. So pi divided by 1/2 is going to be 2 pi, is our phase shift. Okay. So let's graph this. So in the previous ones, right, our midline was 0, so I had this centered. But here our midline is up. So we don't need so many negatives, if any negatives at all. So let's have a little bit more top than bottom. We'll be a little top heavy here. Okay. And then again, our midline is 3, so we certainly need 3, and our amplitude's 2. That means the highest we're ever going to go is 3 plus 2, and the lowest we're ever going to go is 3 minus 2. So 5 and 1 are very important numbers to have included right here. All right. And then again, I usually like dividing my period up into 4 parts. Well, period's 4 pi. That actually very naturally goes into 4 parts. So this is 4 pi, 3 pi, 2 pi, 1 pi. And then we can count negatively as well. All right, so here's where things get interesting. Whenever your midline is not the x-axis, it's a good idea to kind of write it down. The midline is y equals 3. Give a nice little dashed line. This just helps you. You don't need to include this for me, but it's going to help you graph it. All right? And now cosine normally starts at the maximum. Cosine starts at the top. But, and again, the top is going to be the midline plus the amplitude. We have a negative value for A. So this tells us that we're actually going to start at the bottom because of that negative. So we're actually going to start down here. But wait, there's more. Phase shift is actually technically negative here. All right, it's going to be to the left because it's a plus right here. So normally we'd start by here now. But there's a phase shift as well. And the phase shift says we have to move 2 pi to the left. So this is actually where we're starting. Normally it would be up here. But because of the negative right here, we have to go down here. And because the phase shift makes us go 2 pi to the left, this is actually where we're starting on cosine. But that's the hardest part. Hardest part is just figuring out where you start. Because once you do that, well, we already divided our period into 4 parts. So now every hash of our period, we either go to the midline or the minimum or maximum. We're already at the minimum, so the only place we can go is to the midline. Only place we can go after that is maximum, midline, minimum, midline, maximum, etc. All right? And ironically, coincidentally, and quite hilariously, maybe not that funny, we had a phase shift and a negative number. Look, this looks just like a non-transformed cosine function with a positive number and no phase shift. Well, this is just getting us a little extra work. All right. And now you just connect it all and get that beautiful cosine shape. Don't mind this little hiccup right here. Cosine was having a bad day. All right, and that's our graph. All right, so this section is going to be probably one of the more difficult sections until we get into chapter 9, which has a lot of tricky stuff in it. So as you're looking through the homework, if you have questions, send me an email. I always respond to emails within a day. And if you email me during my office hours, it's very likely you're going to get a response within like a minute or something, unless I'm working with a student. Okay. So please send me an email if you get stuck on these homework problems. This is a very important section. Okay. 8.1 is super important. 8.2, we're going to do like a lighter version of it all. And then 8.3 is also very, very important as we really go into the heart of this class, which is going to be chapter 9. We're going to be spending hopefully a fair amount of time in chapter 9 just to get you very, very comfortable with it. Chapter 7 and chapter 8 are preparing us for chapter 9. And if you don't have good foundations, chapter 9, which is already difficult, is going to get way harder. So it's very important to spend some time on this homework. Don't just guess. Spend some time on the homework. Ask me questions, figure things out, check your answers with the back of the book, and really, really get comfortable with it. Okay, that's pretty much it. We'll start 8.2 tomorrow. 8.2 is going to be shorter, hopefully. Hope you enjoyed learning some mathematics, and have a good day.